really well, I thought, as a group. And there were some, there were a few things that I would like to go over. First, so yeah. Well, just out of curiosity, what did you feel about the length of the exam? Was it about right? Too short? I thought it was too short. Okay, well,
I had a comment on that.
sure.
Uh, I thought I felt a little bit rushed towards the end. I really could have used another like around 10 or 15 minutes, but I was able to complete everything.
Okay, yeah, and the just the remote, the people doing it remotely sort of had an extra issue about the challenge was, how do they submit an event graph by drawing when they're doing the thing online? So, so basically I think most of them drew it by hand and then scanned it and then upload, but it's like, okay, that took a little extra time. So, anyway, so I do want to kind of go over it. And if you got the stuff right, then you can kind of zone out for a little bit. But, well, let me see if I can share my entire screen so I can switch between the various things. Okay. Well, okay, so let's look at the in the first problem, I gave you a state trajectory with the information and asked you to extract some statistics from it. There are a few, there are other things I could have asked about this, but the idea was I wanted to make sure that you were actually computing them correctly in each case, and that was for the first part. I think everybody pretty much got it, but it was an area under the curve type of thing, divided by the time, which would give the average. Now, a way to do it is in this kind of tableau form here. Another way would be to just kind of cut it up into these pieces, compute the area of each piece, and add it up. That was done too. Another way was you could actually cut it up horizontally and add up those, however you get the area under the curve. The thing about the area under the curve is for a general function, that usually brings us into calculus land. One of the advantages of discrete event simulation is that because the state trajectories like this are always piecewise constant, bless you, the area under the curve is never more complicated than the area of a rectangle. So that's kind of nice. Then then for the second one kind of required you to kind of do just a little bit of calculation here about, okay, the first customer came in here. I said he left second, which was here. And the second guy came in second, but then left first. So it came in here, left here, he left here. And then there are other things that, so for example, what can I say about the number of servers in the system if this was one of our queues? Is there anything I can say about them? Well, yeah, at least two. Yeah. Because we don't see what the queue is like. And in fact, depending on how many, well, first of all, given that the customers exited out of order, there can't be one. if there's only one server, they have to, it is first in, first out. If there's more than one server, then it gets mixed up. So if they had come out in order, you wouldn't have been able to say whether there was one or more, because, you know, in a if there are more than one servers, then it's quite possible that they still come out for a particular sequence, that they come out in order. But as you run the system, it will tend to get mixed up. One of the things I could have said for like another type of question for this, which these are all things I've asked in the past, and then just kind of I decided not to torture you with. Okay, supposing there are two servers in the system, and my question is, at time, let's say at time 40, does Little's formula hold for the Q? For the Q. And the answer is that it actually does, because at time 40, see, notice if there are two servers and there are this many in the system, then that means that basically you can kind of draw a line at 2, and anything above that is in the queue. So actually at time 40, there was nobody in the queue. So Little's formula actually did hold for the queue, not for the system. That when I've asked that question in the past, it usually kind of stumps people. So, but that's why I didn't ask it. Okay, so all right, that was that was that. And then now on problem 2, I was unfortunately what this was supposed to be was this. In other words, it wasn't just the plain arrival, it was the arrival of customer number 12, because that was the 12th guy is in here. His renege event is over here. That was my bad. And so there were a number of what I tried to do was look at what I'm looking for here is making sure you're processing the event list correctly, which is to sort of take the next scheduled event, which isn't always the one that just has been scheduled, and to make sure that in this case, there were canceling that should have happened at one point. And did that cancel the renege? Were the right events? That's what I was looking for. This typo on my part was unfortunate. So I tried to be as liberal as possible in kind of looking at kind of what you did. So for example, if you just kind of said, okay, well, I'll just assume this is kind of what's happening and take the next arrival and keep processing, then fine. If you, I think some of you would ask me, okay, what the heck is with this? This doesn't match the event graph, which is true. And so I said, well, okay, it should have been this. So some of you did that, and if you did that, then again, that was fine as well. If you got confused by this, and I somehow didn't give you enough credit, see me, and because again, what this was addressing is correctly processing the event list. And the reason that's important is that when we're debugging a model, and you should always be doing this, you should always be running it in verbose mode with the dumper listening to the property changes and making sure that the event list and the events being processed and the states being changed are all correct as dictated by the event graph. And if they're not, then there's something wrong with the implementation. This is assuming the event graph is correct, of course. And so, I mean, it's really important to sort of get this, because this is a little different than what the so-called time step models do. You know, in a time step, you sort of click the clock and then update everything. In the next, starting tomorrow, we're going to kind of do a little segment on what I think is a very interesting application of all this to address it. We're going to leave, at least for a while, the world of queues and enter the realm of things that move around. And how do we deal with that? The standard way of dealing with that is something called a time step model. And just even in what we're going to talk about tomorrow, we'll see how there's an issue with that. That there's an immediate problem with doing things in a time. Anyway, so that's what this was about. Again, it was my bad and kind of that one little thing there. But okay, so that now the event graph modeling. So there were two pieces to this. The first piece was, before I kind of move on here, this is the solution to this as I had envisioned it. And I think some of you got this exactly. Some of you, for some of you, I think because you made a slightly different assumption. Again, I tried to be as lenient as possible in that. Okay, so there were two pieces to this. One is that unlike our our multiple server queue model, if there's an arriving piece, it wouldn't necessarily, even if the kiln were available, it wouldn't necessarily begin processing it. You had to wait until there was a batch. And if you're familiar with these kinds of things, that's how it works. In other words, you don't fire up the first one. You kind of wait until it's full, and then you fire up the whole batch. So that's kind of what was going on here. And then the second one was keeping track of the number of fires that were going on, and making sure that after that you would perform the maintenance. You know, so that so those were the two little pieces of that. And there are, this isn't the only way to do this one. I think some of you had some slightly different things, but some of the key things were, I think everybody got this, that first of all, the condition was, in addition to there being an available server, the kiln in this case, that the queue had to be at least the size of a batch. And I think you could make this equal in terms of coming from the arrival event, but you still have to be a little bit careful with that. So greater than or equal to is just a little safer. And well, there are a couple of different ways of doing it, but you need at least two conditions. That is there enough for a batch, and is the server available? There are two ways the kiln cannot be available. One is if it's actually firing, but then the second is if it's under maintenance. So the thing is that when you finish a batch, that's when we kind of increment, or now you could increment it at the start batch, but the thing is that you know, just sort of thinking of how these things work, it's like you don't fire and do maintenance at the same time. You know, so it's like you finish firing and then you do the maintenance. You know, so there was anyway. So so when you finish a batch, so we have our kiln back available. We've incremented the number of firings that we've done, and then the question is, has it reached that maximum so that we have to do the maintenance? If it has, then we do the maintenance. We kind of reset our M back to yeah. Well, yeah. Here it's like now, if there was like if we had to queue up for the maintenance worker who's doing this, then we would have to have an extra event. Here notice we're just scheduling, we can just schedule the end because we're not queuing up for it. Why? There's only one kiln, and you know, you're either firing or you're fixing it, you know. And thinking with these, periodically they have to like take them apart and kind of redo the bricks or something. And then when we finish the maintenance, we've, now in this particular case, I had, you could have an extra event that would set the available kiln back to 0, et cetera. Here, because of these extra conditions, in other words, until end of maintenance happens, the M less than M condition is not going to hold. So this whole thing is going to be sort of keep you from grabbing the kiln even when it's under maintenance. That's the thing you got to prevent. And there were a number of different ways of doing this, and hopefully I kind of got there. But then once we have the kiln back after maintenance, then here the condition must be if while you were doing the maintenance you got more than a batch worth of parts, then you can only do the batch. So the equal here will definitely not work, because while you're doing maintenance, you could have more than a batch worth. Okay, any questions about? Yes. Yeah. Yeah, that's just a regular arrival process. Yeah, it was the TA on the Reneg model in the exam that was there. That basically what happened. Where the heck is it? Oh, I think I. Wait. Oh, yeah. Sorry. I just for the next time I do something like this, I made a simpler event graph. But the TA, what happened was in the drawing program I was using, the TA from run to arrival got on the arrival to arrival is what happened. Because okay, so now so what I want to do now is, let's see, am I still? Okay, so what the thing about that, I want to talk a little bit more about that kiln model, because that's again just a slight modification on what we've been doing. Where if you remember, there was an assignment where the arrivals were in batches, and we could add that into this, as well. But here, this is the flip side of that, where you're only processing them in batches. So, but in that model, there was only one kiln. Can you think of why there was only one kiln in that model? Why wasn't there like K kilns? Yeah. Exactly. In other words, just the counting isn't going to work here, because it's like if I have two kilns, one may have different numbers of firings until they need to have their maintenance, and I need to keep track of which is which. And I can't do that just with one count. So let's do that. In other words, what is it going to take if we want to have multiple ones? Because again, in most of these facilities, there's generally more than one. Okay, so what mechanism do we have that would allow us to kind of keep track of each individual kiln? Yeah, an array. Now, and we could have just an array of integers, where the integer was the thing that would be the simplest one, or we could have an array of entities, and that way we could actually have the potential of maybe doing a little bit more. So let's see what that would be about. Okay, so let me. This is my little drawing program. So. All right, let's start with an entity. What do we call it? Let's call it a piece. I'm sorry, no, our entity, it's gonna be a kiln. The pieces are, we're just gonna keep counting. And then for this, I would want an attribute of the, of an int number of firings. That's kind of small there. Let me make that bigger. Okay, and so what types of things might I want to do on this? Well, might want to reset them. And the other is, wait, let's go increment. These people. All right. Okay, so let's have these. Now, what would we want in terms of our parameters? You a bit bigger as well.
Sir, can you share the screen by any chance?
Question?
Can you share the screen?
I
Sure.
mean, I haven't, sorry. Okay, so, right, here's the kiln, and in terms of parameters, let's have an array of kilns. And just some other things that we will need. We'll need our firing times. We'll need our maintenance times. And we will need, let's see, we will need our batch size. And we will need the number of firings. Okay, so those are our parameters. And for our states, okay, so for our state variables, let's have a the number in the queue. It's going to be 0 to start with. Let us call this O. Yes, for sure. So this will be a container of kilns, of available kilns. And it will initially be initially be all the kilns. And then we will need, actually, that's really all. I think that's all we need. Can anybody think of another state variable? Well, maybe one will come to us as we kind of move along. All right. That's a good question. Do we need multiple container for the multiple kilns? I'm gonna say, I'm gonna try to do it without them at first. And then we'll kind of see. But that's a good thought. But just in the interest of minimalism, I'm gonna try to do it without. And I'm gonna assume an arrival process is gonna drive the whole thing. So we're not gonna worry about that. Okay, so we always start with our run event. Let's make. And for our run event, we will initialize our queue to 0. And I'm going to clear this. Why? Because I'm going to use the whole init little business to okay. So to initialize this, and this is kind of the pattern when you have an array of these things and you want to kind of put them in one at a time. Okay, why clear it even though it's going to be empty at the very beginning? That's because eventually we're going to be doing multiple replications. And we want to do multiple replications within the same virtual machine. And what that means is we're going to kind of reuse the same objects. And so when I finish with a run, then in this case, what's going to be in here is going to be what was left at the end of the last run. So just to make sure it's absolutely clean, I'm going to do this. So I'm basically going to add the ith kiln. And actually, I'm going to stamp the times, and the reason is because I want to kind of rotate them. And so to do that, I'm going to have the container be a sorted set. And so, okay, so that's that. Now let's deal with that. Now notice that I am only dealing with our state transitions and the events. I'm not trying to connect anything yet. But we're going to have an arrival because that's going to increase the number in the queue. Okay. Maybe if I make these. Okay, so now what, so just as, remember that we had a model where we had entities for our servers, and that's basically what we're doing here. And so we can pretty much apply the same issue. So now when we start firing, we take away a whole batch worth of stuff from our queue, and then let's pop off a server from this, okay? And then if we have a start firing, we're going to have an end firing. But the question is, since we need to keep track of who was firing, we're going to need to pass it. So I need to have an argument, and the argument is going to be the kiln that just finished firing. Why? Because now I can So for that kiln, what did I call it? The number of firings, I'll call it N. Well, just increment. I'll increment that. And I will stamp him. Because I'm going to now add him back in. Okay, but now I need to deal with the maintenance. So let's now. Now I want to do it in two separate events, because what I want to do is I want to pop off. I'm sorry, not pop, but remove that Kate guy from the thing. I'm going to assume that there's also no queuing for the people doing this. If there were, then we would have some additional events. But now the other state transition is when we finish maintenance, now I can add them back in. And basically that's. So in this case, now, why didn't I have a container? That would have made perfect sense. But notice that I'm not going to lose any kilns, because they're either on this container, or they're an argument in one of these events. And so either way, I'm not, they're not going to get lost. Now, if you want to be careful, extra careful, belts and suspenders, you could do that as well. And that would be a useful addition. I'm not going to do it here, but if you had a question like, well, what is the average number of kilns that are in maintenance, then I'd have to do a little dance to answer that here. You could, but you didn't have. Check the chat here. They're saying, oh, you're not sharing the screen. Okay, but everybody's seeing this now, I hope, right? Okay, so now, yeah. Thank you, yes. So, okay, reset. Thanks, yeah, that would not, if you didn't reset it, then you'd never be able to use it again, so. Okay, so now we can kind of start kind of doing this little business. And then, we've done this a number of times here. So this is how we initialize. Oops. One of these guys, oops. Two of these eyes, I only want one. And then, here it's I is less than. Okay, so now for the fun part. Now we have an arrival that may schedule a start firing. And what are the conditions for this? Well, first we need to make sure we have enough in the batch, and I'm going to be safe and say greater than or equal to. I think equal probably would work, but if you're paranoid, just this way, if somehow it slips to be a little bit bigger, and we also need the these guys, they're to be an available kiln. See, okay, so enough in the batch and an available kiln. Now, unlike the other one, we don't need to check to see whether, because we've taken them out of the kilns here, out of the container. This is all we need. Because when it's in maintenance, it's not in the available. So that's. Okay, so now when we fire, I'll need to, first of all, pass my kiln. And then have our firing time. Oops. And we're passing, let's make this bigger. Okay, so now when we finish firing, there are two possibilities. One is that well, first, have we reached maintenance? So if N is less than M and our Q is bigger than or equal to our batch size. All right, the N is if we're not ready for maintenance, then we'll have that as the condition there. And then otherwise, if we reached our time for maintenance, then we schedule that and we should pass it K, our kiln. And so now with 2-0 delay, flip that. Oops. So with 2-0 delay things, you might kind of worry about maybe these two being simultaneous, but that can't happen because the two conditions are mutually exclusive. Yes, thank you. Yeah, so if the kiln has reached its limit, and then now notice that since this isn't a queue, we can simply schedule our maintenance. And then we want to pass it a K with a delay of our maintenance time. And then now finally, when we finish our maintenance, we can, we don't need to pass anything, but we do need to check to see whether or not. Let me flip you. Why does it do that? See, it's acting up, but the condition, of course, is that the Q be bigger than or equal to our batch. Let's make you a little bit. Okay, so that's how we kind of generalize that model. And to go from one kiln to multiple kilns, keeping track of each one. And the point of this is that it gets back to this sort of incremental modeling that I've been ranting about all quarter. You know, in other words, start with the simplest possible model. So this was the simplest possible model. We'll assume, you know, even if there are multiple things, let's do it for one to see whether we can capture the idea of the batches and the idea of the maintenance. And then this will also give us some insights into how to go about doing it. That, in other words, having done this model, going to this model is a relatively short step compared with just doing it from scratch. Yes, question. Well, for this, I'm assuming that there's going to be an arrival process we're going to listen to. But yeah, good. Yeah, the question is, what about the arrival? If we're doing a complete model, then the answer is yes. Because this model, if this were all there were, then the runs and the inits would happen and then nothing else. But if we were to listen to an arrival process, then the arrival events would trigger this and then it would be on our way. Doing it this way gives you a little more flexibility. So for example, this may be one step in a multiple step process. And so these things may be coming from another process. If I hook the arrival up, then I can do this model, but I can't do anything else. If you remember a while back, we took the simple multiple server queue component, and by using adapters, we were able to turn it into a transfer line but without adding any additional code, just by kind of hooking them together. And similarly, if we have another type of process, it could be like a regular multiple server queue, it could be some kind of transfer line like thing. It could, you know, it could be almost anything else that we can then insert this into a step in that multiple process. So it gives it that flexibility. Now, if the problem is, as in the exam question was, okay, this is the problem. There is no more, this is the answer, or this is an answer, and that's fine. But my experience in creating these models is that the more leeway you give yourself to being flexible at the other end, the better off you'll be. Because in each and every case, every time I've delivered a model, there's always been, hey, can you make it do this? Or can you make it do that? Or what if we, you know, and actually, I mean, right now I'm involved in the most complicated version of that, where it's like built a model to do one thing, and then somebody else saw that, and then they said, hey, this is great, but we wanted to do this other completely different thing. And okay, so that took a look. To do that other thing from scratch would have been a huge effort. To add on to the other one in a similar manner, I was using this listener idea, and I was able to leverage all the work I'd done on the first model to do the second model in not only in a much shorter amount of time, but in a more reliable time. In other words, having debugged and verified, say, an implementation of this, then if I want to kind of add something on, then I don't have to re-verify this. Because if you notice, the thing about this listener thing is that it really, it's encapsulation is sort of the key. And it encapsulates the states. The states are very much encapsulated in the sense that, you know, no other component is supposed to be able to these states are only a function of their initial values and what other state transitions have happened and when they happen. That's it, nothing else. Nobody else can touch them, or at least in theory. I mean, in practice, you can do all kinds of evil things. Okay, so that's what I have for today. Now, tomorrow we're gonna be applying some of these things to a completely different problem, and we're gonna begin with the problem of this is, I get this pushback sometimes in talking with colleagues who are not aware of some of the things you can do with these event models. They say, well, you know, this discrete event stuff, that's fine for these queuing systems and everything like that. But, you know, I have an agent model, or I have a combat model, and I want to have entities that kind of move around on a battle space, and I want them to interact with each other. And you can't use discrete event for that, right? Well, we'll see. And we'll see tomorrow.